All right, thank you for having me. So my name is John Fragalla. I'm a Principal Solutions Architect with Xyratex. For the next 20 minutes, I'm going to only have one product slide. And the majority of the presentation is just really talk about how to build a resilient parallel file system storage subsystem, and what the basis of from the hardware perspective and the software perspective to really build a highly resilient storage subsystem for HPC. So over the last couple of years working at Xyratex, one of the things that I've noticed in the trends in HPC overall is that adding more flops and more accelerators addresses only an aspect of an overall performance for an application. The trend that I've been seeing more and more is provide and build out a highly throughput and highly capacity file system to really drive the other aspect of application performance is data access and data execution during an application runtime. And one of the things that I've also noticed is even though a file system might be called /scratch or /project or /home, downtime is not tolerated anymore, regardless of what we traditionally might think of a Lustre parallel file system based on version 1.4 or 1.6, where downtime might be considered acceptable in certain aspects of a file system. The trend is any amount of downtime hurts application performance, hurts researchers' time trying to find certain outcomes of an algorithm. So, and more, throughput and capacity is taking a back seat to features like redundancy and availability. Even though those other two aspects of throughput and capacity are critical, high availability and always have access to data is becoming more and more critical as a guideline in RFPs and tenders. So when you look at building a redundant and reliable HPC storage subsystem, it all starts with disk drives. And what I mean by that, it starts with the type of disk drives that are being used, the testing and regression testing that's being leveraged in a solution, going from the bare metal individual drives into the overall solution. And then the other aspect of it is looking at just the architecture and the redundancy built into the hardware. And then thirdly, having software built from the ground up with HA features as a standard into that solution is critical as all aspects of a redundant solution. And lastly, just for a management capability is customers and end users want to know how to manage a system like a complex system that involves Lustre parallel file system, not just on the Lustre level, not the software level, but everywhere from bare metal to the application. They want to know end-to-end system management and what kind of throughput they're getting at a per user basis, at a per application basis. And lastly, integration and testing from all ends of the spectrum of the solution is key to making sure the system is reliable and available. So let's talk about disk drive testing. And what I've seen in terms of working at Xyratex is really three phases of disk drive testing into a solution. First phase is just looking at the individual drive component and what kind of rigorous testing that is being done to make sure that any issue with the drive itself is found out before it's integrated into a chassis or overall storage solution. So that's one thing, is you need to have a good guideline and methodology of testing individual disk drives. Secondly is once it passes that first fundamental test of phase 1 testing, integrating those disk drives into a chassis to do more fundamental testing of vibrational testing, connectivity of the SAS or fiber channel connections as well, is also very key to figure out additional issues with the solution. And then third phase is when you integrate the disk drives into the chassis, is then install the software and the file system and then do additional regression testing on top of that to find out additional issues with the overall solution. So there's three aspects of trying to figure out issues in manufacturing with solutions based on a parallel file system before having it arrive at a customer site, to work through all the kinks and to make sure when the system arrives at a customer site, it has gone through these phases of testing to make it as reliable as possible before applications start being executed and data is being stored on the storage subsystem. The other thing is you want no single point of failure in the hardware. And what does that mean, no single point of failure? So really it involves at what level of integration you're building the Lustre parallel file system at. So the first aspect of it is your basic building block for object storage servers and the disk drives that are exporting that devices out as OSTs. So you want to have redundancy as power supplies, redundancy in the fan trays, redundancy in SAS connections, and redundancy of just number of expanders that you have in the chassis to make sure that you could withstand any failure in hardware. Secondly, if you're integrating the solution into a rack, then having redundant rack PDUs and possibly redundant power grids into those rack PDUs to actually survive a catastrophic power outage of one power grid so you can still service data in those cases as well. And secondly, power outages are just, you could try to build a solution and avoid power outages as much as you can, but UPSs are still critical to protect certain aspects of a storage subsystem. It could be protecting the metadata and management functionality, so those services will stay up and gracefully shut down if the power outage exceeds the battery life of a UPS. So you could gracefully bring those systems back up and then bring up the rest of the service cleanly without having to have a storage subsystem crash uncleanly during an unexpected power outage or power glitch. So UPSs and targeted UPS protection is critical. And then phase 2 approach is looking at just the Lustre file system itself, is building HA services from redundancy on the metadata, redundancy on the management servers, and redundancy on the object storage servers. So if you have a server that fails, or a operating system that seems to just panic, you could survive a hardware failure by failing over resources. And the key component here is you're not trying to protect against failures in terms of we want to avoid any failures. You want to protect against data access loss. So you know that you might have failures during the course of a storage subsystem running for many years at a site. The key is providing HA services to survive those failures, to continue delivering data so applications can continue to run. Thirdly is end-to-end system management to get notifications of services that are offline and had to be failed over to continue access so you could remedy the hardware issue or remedy the software issue to quickly bring back the service at full throughput and full functionality of the original configuration. So end-to-end system management, getting notifications of when drives fail, or when controllers fail, or when a rack PDU fails, or when a power supply fails, is critical to remedy the problem, to quickly bring up the solution back to its full capabilities. And then lastly, to deliver data is majority done over a high-speed network like InfiniBand or 40 gig Ethernet. And you want to provide the functionality of any aspect of a high-speed network failing. So that means if you look at just the basis of it, if you have a high-speed network card that fails, that means you have loss of access to that particular OSS, and that means you would have to fail over resources because you lost access either because of an InfiniBand cable has gone down, or a 40 gig Ethernet cable has gone down, or just the driver in the operating system panicked and no longer serving data, so you want to survive that capability at the minimum. Secondly, you want to be able to survive a catastrophic switch failure, and this is assuming that your infrastructure has redundant core switches and also redundant leaf switches, and the ability that if you have a leaf switch that has completely failed or is unresponsive, or a core switch that has completely failed or unresponsive, that you still be able to survive that error, an issue, by taking HA and automatically failing over the resources, even though you might not be at 100% full throughput capability, but the key is you're still delivering data and delivering access to that data, and applications are continuing to run. And that's the key here, is during a failure, you might not be critical with throughput, but data access is critical. And these are all the hardware redundancy features one must look at to protect against any type of level of issue to continue serving data for applications to be running on a compute environment. On the software side, your software stack should be built from the ground up with HA services included within the infrastructure, meaning that when you build a storage subsystem, HA should not be an afterthought, but should be in the foreground of how you build your overall Lustre storage subsystem. And HA services to identify key areas to protect against failures so you could do automatic failover of key resources to continue delivering data is what the software should be designed for. And it should tolerate any type of failure to continue data access. And that could be in your management infrastructure. Even though management is key to understand what is going on and to get alerts and notifications in the storage subsystem, but the management network, if it fails, is not critical to continue servicing data. It's critical for your administrators, but not critical for serving data. And that's the one thing that users will always yell about, is if during an application being executed, if they don't have access to their data, the administrators will yell at the sites to say, my data is no longer accessed. And if your application does checksums, then you resume from the last time you do a checksum, or checkpoint, I should say. If your application is doing checkpoints, then you just resume from the last time you did a checkpoint. But some applications don't do checkpoints. So for those users, you need to restart an application even though it's been running for 10 or 20 hours. So that's why data access is always critical. The other benefits of having HA built from the ground up in a storage subsystem, in addition for always surviving and giving out data access, is you could do other creative things with HA. You could do live system maintenance without having to take down the system. Leveraging failover and failback of those resources, you can provide live system upgrades of a new software image that has new functionality and new features for a file system. Or if you know that you have a hardware component that has failed, you could fail over the resources using HA, provide live system maintenance, and then fail over the resources back. And then the other piece of it as well is your data protection layer is also very key. So standard in most storage subsystems is double parity RAID 6. We're seeing trends going over parity declustering. There's a lot of discussions around that. But the requirement of doing hardware RAID controllers is becoming less of a requirement, because if you look at what a hardware RAID controller is, it's specialized hardware, sometimes based on x86, with an operating system, configuring data protection, exporting that data protection to a file system that mounts OSTs and exports it via Lustre. So if you have enough compute resources on your controllers, and you could be able to provide the same data protection layer and without sacrificing performance, then the use of dedicated RAID controllers become less needed, and you could build all the HA functionality with software RAID into your overall solution and save costs with dedicated data protection on the dedicated RAID controllers. So software RAID is becoming more leveraged, and performance is not being hurt by using software RAID versus dedicated hardware RAID controllers. And then lastly, integration is also key. When I talk about integration, is the level of testing and manufacturing going from integrating the disk drives into the storage controllers, into a rack, configuring the software stack, and purpose-built the solution for file system performance and availability, and doing a lot of soak testing, vibrational testing, running through various cases of failures to ensure that all this manufacturing and integration and testing is done before it hits the customer site. Because at the end of the day, we could find out a lot of the issues in manufacturing, and what the customer is going to see is what failures are going to happen when the system hits the site. And a lot of the integration and methodology that happens in manufacturing could find a lot of the problems before it hits the customer site and avoid doing on-site integration, which also increases your overall reliability and availability of the system. The foundation of HA, resiliency, reliability is what Xyratex has built into ClusterStor 6000. ClusterStor 6000 delivers up to 42 gigabytes per second of file system throughput with Lustre over InfiniBand or 40 gig Ethernet. It's a soft cap, but we're able to sustain 1 terabyte per second of throughput, and we've actually seen this sustained working with our partner Cray at Blue Waters. And an overall scalable storage capacity of over 100 petabytes. And those are soft requirements because we haven't seen the limits of that yet. The largest deployment that we have is with our Synexion product line with Cray, up to 25 petabytes of storage. We support natively within the rack FDR and 40 gig Ethernet. Outside of the rack, we could support 10 gig, 20 gig, 40 gig, QDR InfiniBand or FDR InfiniBand. We could support up to 560 data drives, removing the data protection parity drives, removing the global hot spares. That's how many data drives we have. And with 4 terabyte drives, about 1.8 petabytes of usable storage per rack. We do all the integration, all the testing, all the system tuning for Lustre in manufacturing before it hits the customer site. Everything is fully cabled and wired in manufacturing. So when it hits the customer site, the only thing that needs to be cabled is the connection from the top of rack switches to the core switch at the customer site. And because of the manufacturing process and testing, our annual failure rate that we've seen in ClusterStor, and the key area here is look at the dotted line in orange, and our average failure rate of disk drives in ClusterStor 6000 is less than the industry average of 2%, and in our case, we've seen an average of 0.5% of disk failures annually in our solution because of the integration process and testing that we do in manufacturing before it gets shipped on site. So in summary, the ClusterStor 6000 product line is purpose-built for Lustre, taking into account high availability and resiliency without sacrificing performance. Thank you.